Hello, today we'll talk about charging by induction. And we can charge by induction, and the system can be grounded. You remember we said that when the object is connected to the earth, we call this grounded. When the system is connected to the earth, initially the current will flow, and then after some time, the time is very quick, and then there's no current flow. That means the potential is the same. That's the meaning of grounded. And you note that the earth is huge. So the earth is a huge reservoir for electrons. I didn't emphasize that all the electrical phenomena in this course is due to the motion of the electrons. And the Earth is the huge reservoir of electrons. So it can give the electron to the connected system, or it can absorb the extra electron from the system. So let me look at the figure A. We bring a positively charged rod near the neutral conductor. Then, as you can see, electrons in the sphere will be attracted to the positively charged rod. So we have charge separation here. In this part, we have bachelor ions, and here we have extra electrons attracted to the positively charged rod. Now we connect this conducting sphere to the Earth. Remember, the Earth is the electron reservoir, and we see here we have extra positive charge. Then electrons in the Earth will be attracted to these bachelor ions. So electrons will move from the Earth to the sphere, and then there will be no bachelor ions here. Okay, and then we disconnect the wire to the Earth. And still we have extra electrons here, and we remove the positively charged rod. Then we can see that here we have negatively charged sphere, so we can have a negatively charged sphere. So we can charge this conducting sphere by ground. Sorry, I pressed the wrong button. Let me come back to the original part. Okay, here we are. So this is the way how we how how you charge the conducting sphere by grounding with the with the grounding. Okay, let me move on to section 5.3, Coulomb's law. Suppose we have two charges, Q1 and Q2, and let's say the distance is R sub 1, 2. And then Coulomb did the experiment. And then he found that the force between the charges is proportional to the charges Q1 and Q2. And then it is inversely proportional to the square of the distance. So he found this relationship by the experiment. So he discovered the electric force between two charges. And then to have the dimensionally correct expression, in the left hand side we have force, and in the right hand side we have charge q square over distance square. So to have the correct dimensions, he introduced the constant, which is 1 over 4 pi epsilon 0. And he notes that when two charges are having the same sign of the charges, the force is repulsive, whereas the signs of the charges are different for unlike charges. So Coulomb force is attractive. The constant epsilon 0 is called permittivity of vacuum. It is defined 8.85 times 10 to minus 12. The unit is C square over Newton times meter square. Sometimes we use K, which is equal to 1 over 4 pi epsilon 0. Then the constant K is about 9 times 10 to 9 Newton meter square over Coulomb square. So let's see Coulomb's law again. The electric force between charge Q1 and Q2 is 1 over 4 pi epsilon 0 Q1 Q2 over R sub 1 2 square. And this is the vector between charge Q1 and Q2. So the direction can be negative or positive depending on the signs of the charges. Let me solve the example 5.1. Here we calculate the force on the electron in hydrogen. In hydrogen we have a single proton and a single electron. And the proton has a charge of plus E, whereas electron has a minus E. Suppose the proton is at the center of this coordinate system, and let's say electron is here, and the distance is r. Since they have different sign of charge, electron will be attracted to the proton. Proton has a plus E, 1.6 times 10 to minus 19 coulomb, whereas electron has a minus E, which is equal to minus 1.6 times 10 to minus 19 coulomb. And the distance between the electron and the proton is about 5.29 times 10 to minus 11 meter. So Coulomb's law is given by this expression. F is 1 over 4 pi epsilon 0 E square over R square. So we substitute the constant for epsilon 0, and the electric charge E is 1.6 times 10 to minus 19. So we square this, and then the distance is 5.29 times 10 to minus 11 meter square. So we calculate this expression, then we find 8.25 times 10 to minus 8 Newton. And here the direction is toward the proton. I think there's a missing minus sign. Suppose we have many charges, then they interact each other, and then we have a principle of superposition. What that means is, if we look at one charge, and that one charge will have the force from other charges. So we add up all the individual forces acting on the charge. That is called principle of superposition. So this is the force acting on charge from other electrons. Suppose there are n plus 1 charges. Let me look at one specific example. Suppose we have a charge capital Q here, and then we have 8 other charges around, and then each charge from Q1 to Q8, they will apply the forces on capital Q. So we add all those forces acting on capital Q. That is called superposition law of superposition. So let me look at one specific example. Example 5.2. The net force from the source of charge. Suppose we have a charge Q2 at the origin of this rectangular coordinate system, and the Q1 is on the y-axis, whereas Q3 is on the x-axis. Notice that let me check the sign of charges. Okay, Q1 is 2e, Q2 is minus 3e, Q3 is minus 5e. So if I look at the force acting on Q2 due to Q1 is in the positive y direction because they have different sign, so the force is attractive. So the force is acting in the positive y direction. And then the force between Q2 and Q3 are repulsive because they have both negative signs. So we have force F21 in y direction acting on Q2 due to Q1, whereas force F23 acting on Q2 due to Q3 is in minus x direction. And according to the law of superposition, we need to add this force and this force, and then the total force will be like this. So we want to calculate this total force. So the total force is the sum of each force, and F21 is 1 over 4 pi epsilon 0 Q1 times Q2 divided by the distance square R sub 2, 1. And you remember this force is in the positive y direction, whereas F23 is in negative x direction, and the magnitude is 1 over 4 pi epsilon 0 Q2 times Q3 divided by R23 square. So you note that we have one x component and one y component. The x component is due to Q3, so we substitute the numbers to each epsilon 0, and we know the charge Q2 and Q3. So we calculate, and the distance, so we calculate this, and then the x component is minus 2.16 times 10 to minus 40 Newton. For the y component, we have Q1 times Q2 over R21 square, and Q2 is 4.8 times 10 to minus 19 Coulomb, and Q1 is 2e, so 3.2 times 10 to minus 19, and distance is 2 times 10 to minus 7. We calculate this expression, then we find 3.46 times 10 to minus 14. So we can calculate the magnitude of the total force, which is equal to square root fx square plus fy square. So we substitute these numbers to here, then we find 4.08 times 10 to minus 14 Newton. So this is the magnitude of the total force. And then we can calculate the direction of the force with respect to x-axis. Here, let me see the figure. So here you note that the total force is in the direction. So we want to calculate this angle or this angle. So let me calculate this angle. So this angle is equal to arctangent y component divided by x component. So we solved the x component and y component, and you remember we have minus negative x component, so you find the minus 58 degree. What that means is the force is in this direction, not this direction. So this angle is 58, but the force is in that direction. Okay, now let me move on to the next section, 5.4, electric field. People note that Coulomb's law has a problem. It is called action at a distance. I don't know whether you can read this statement. But, Coulomb's law says that if we have two charges, we have a Coulomb's force immediately. And people note that that is impossible. So they want to correct that problem, and then they note that you can introduce electric field, and one charge produces electric field, and then that electric field is transferring with the speed of light, and then electric field will interact with the other charge, and then it produces the Coulomb force. We'll talk about the details next time. So let me stop here. If you have any questions, you can send me an email, and I will answer the question. Thank you. Bye.